Okay, I think I got this set up. I had to reinstall everything because my computer was re-imaged. So I think hopefully this works. All right, optics study guide. Okay, so we said that a lens is a transparent, that means we can see through it, transparent object designed to refract or bend light in a certain way, a predictable way. Okay, so lenses are designed to work a certain way. And with lenses, there's a few important parts. Okay, we've got these two special points. I've mentioned these a number of times. These are called focal points. So I'm going to label these two like so. These are our two points that light refracts through. And every lens has these on either side of the lens. They're imaginary, but they're there. And light rays are going to bend or refract through these in order to create images. Okay. These are a fixed distance from the center of the lens, and that's called the focal length. So this is a focal length right here, and this is a focal length right here. These are equal, so this point is the same distance from the center of the lens as this point is, okay? Um, and that's, again, that's part of the design of the lens, is that these focal points are a fixed distance, focal length f, from the lens, okay? Then we've also got a horizontal axis that we call the principal axis. And that runs through the center of our lens horizontally. And then we can also make a vertical axis that we use called the vertical axis. Okay. Okay, and then what happens to a ray of light when it hits a convex or converging lens? Okay, so this is our lens that looks kind of like a narrow oval. And what happens, these light rays are coming in, doo-ba-doo, they are going to converge or come together at a point. So they converge towards a single point. That's what it means when we call that a converging lens. Okay. I'm trying to make sure my handwriting is good on this video. Okay. Then a diverging lens, that's our concave, our lens that looks kind of like the sides are caved or bowed in. For this lens, light rays come in and then they go apart from a certain point. Okay. So light rays diverge or move apart from a single point. Okay. So converging means they come together at a point. Diverging means they move apart from a point. All right, I'm just going to draw a ray diagram for this setup. So I really need a ruler, but I didn't grab one. So I'm just going to freehand it, which is kind of scary. But when we draw a ray diagram, we're going to draw 3 rays, okay? Our first ray is going to go from the top of our object. This is our object, by the way. Okay, our arrow right here is our object. We want to make an image of this object. Okay, so here's our lens. Here's our focal points. Here's some points beyond our focal points. We've got our principal axis. We've got our vertical axis. Okay, so we're first going to draw one light ray that goes parallel to our principal axis. And when it hits the center of the lens, it's going to go through the focal point on that side of the lens, which is the opposite side, okay? And then it's going to keep going because it's a light ray. Remember, rays go on forever. Then the second ray is going to go straight through the center of the lens, like so. And then again, keep going out this way, okay? My third ray is going to go through the focal point that's on the same side as the object. Okay, so see how these light rays are bending through these focal points. This top ray bent through this one. This third ray bends through the one on this side. That's why those points are special. This one's going to come down, and when it hits this vertical axis, and I didn't draw this very well, it should hit down here towards the bottom of the lens, but it's going to refract across parallel. So good reason for you to have a ruler, because mine's kind of messy, but basically where our light rays come together, we're going to end up with an object. I mean, an image of our object. Okay, so this is our image. And let's see, how can we describe this image? So this is a real image because it's on the opposite side of the lens as the object. This is an image that we could take and move around. We could project it in different places if we needed to or wanted to. So this is a real image, okay? We can see that it's inverted because it's upside down. So inverted. And it is larger than our object, and we can pretty clearly see that here. I think here our object's kind of small. Here's our image. It's definitely larger. So larger. Sometimes our image is going to be larger than the object. Sometimes it's going to be smaller. In some cases, it could be the same size. It depends on the lens and how everything works. Okay, if an object is placed at F for a convex lens, will an image be formed? If not, why not? So the answer to this is going to be no, okay? So let's really quick draw a convex lens. Here's our two axes. Here's F. And then I'm going to put my object at F, okay? So I can draw this first ray. It's going to hit the lens and then go on through. I can draw the second ray. It's going to go on through. I can't draw the third ray because the third ray should go through F here like this one does. See? But it can't because the object is on F. So what happens is that my rays never merge together into a point like they do over here to form an image. They just keep going off parallel forever. So light rays go parallel forever, and no, we can't form an image because our light rays do not converge to a point where we form an image. They just keep going and going. If we're on the point that we need to refract through, then we can't refract through that point. So we won't form an image. Okay, one more for this video and then I'll have to stop. Okay, draw the ray diagram for the following setup. So this is a concave or a diverging lens. Okay, so with this one, it's different because our light rays are going to diverge or move apart from each other. So our first ray hits the lens and it goes off like that, okay? And then there's a virtual ray that comes back from that one. Then we've got our second ray that goes through the center of the lens. And my image, this is really small, my image is going to be right here. So this is my object. This is my image. With concave lens, we always get the same type of image. We always get a virtual. Virtual means you can't project it. It's like it's inside the lens or the mirror. Mirrors make virtual images. When you're in front of the lens or you're on the same side as the object, you get a virtual image. So you've got to be on the opposite side, like this one, to get a real image. If you're on the same side, you get a virtual image. It's upright, meaning it's above the axis here. It's normal, like a normal orientation. And it's definitely smaller. And that's always the kind of image that you get with a concave lens, no matter where you put your object. Okay, so I'll continue in the next video.